Okay, uh, very good afternoon to all of you, and very good afternoon in Aniki Dunya over here. We are live today for the class of physics. We'll be discussing about 30 MCQs of the boards which would come in the exam, which would be probably most important in the exam. As you know, we have already discussed biology questions in the last yesterday's lecture. So in today's lecture, we'll be discussing about 30 most important MCQs of the physics, which we are going to discuss over here. Okay, so I guess it will be very much helpful for you, and ये आपको एग्ज़ाम के लिए कुछ ना कुछ मददगार ज़रूर रहेगा. ओके, तो बिना ज़्यादा देरी करते हुए हम शुरू करते हैं अपना क्लास. ओके, लेट अस स्टार्ट विद द फर्स्ट question over here. Let us start with the first question. The question says that a mirror magnifies the image of an object by minus 1.5 times. Which of the following is true about the image produced by the mirror? Now what information is given to us? यहाँ पर हमें क्या बताया गया है कि magnification, our magnification is minus 1.5 times. Okay, and magnification is minus 1.5 times. So the value of magnification with its sign provides us a lots and lots of information. First of all, this negative sign predicts that, this negative sign says that it is an inverted image. It is an inverted image. That is what this negative sign tells us. And 1.5, which is greater than 1, hence it shows that it is a larger, it is a bigger value. So bigger means it is the image formed is larger than the object which is given to us. That is why it is magnified to 1.5. Okay, so let us check with the options which is the more appropriate for the given question. Image is real and larger than the object. Image is real and smaller than the object. Image is virtual and larger than the object. Image is virtual and smaller than the object. Now obviously image cannot be real, because for real images, if we are to use lenses, then it is not possible. In concave lens, it is always diminished. So what kind of lens it should be? In convex lens, it should be. Okay, hence over here we will get a virtual image and larger than the object. So C is the answer. Now let's move on to the next question. The next question says that the image formed by the concave mirror, is real, it's inverted, image formed is real, is inverted, and of the same size. It has not been magnified, it is of the same size as that of the object. The position of the object should be. Now there are clues given to us in this question, some hint given to us that image formed is a real image, also it is an inverted image. And the most important clue is it is of the same size. So same size image can only be formed when we have provided our object to be on center of curvature. When we have provided our object to be on center of curvature. And when we provide our object on center of curvature, we also get image as inverted and real. So among these options, I would say that the answer is at the center of curvature. Okay, chalo. Now let's move on to the next question. The angle of incident eye and refraction, are equal. Means here we are saying that incident and refraction are equal. They are not less than or greater than. They are equal to one another in a transparent slab. Now that ray of light is traveling from the transparent slab when the value of I is. And what can we say? What should be the value of I? Now if we observe properly in the glass slab experiment, when an incident ray is traveling on the slab, what will you observe? That it is bending toward the normal. So let us say this is a normal. So it is bending, away from the normal, bending away from the normal and passes. That is what refraction means. But when is it possible that it is going to go a straight line? It is only possible when incident ray itself is on the normal ray. When incident ray itself is on the normal ray, then and then only it is possible that we will get our answer as 0 degree. Hence, our answer is 0 degree rather than being an answer as anything else. For any other form of angle, it would get refracted, and the refracted angle would be more than the incident angle. Okay, but it is only possible that they are equal when the given line, incident line, is coinciding with the normal line. Normal line. Okay. Next question. A concave mirror of focal length 20 centimeter. It is a concave mirror. It has a focal length of 20 centimeter. Forms an image having twice the size of the object. Twice the size of the object. Magnification is 2. Magnification is 2 that we can say for the virtual position of the object. The image is formed is a virtual image. Image formed over here is a virtual image. The position of the object will be at. What could be the possibility of having our object placed at B? Now it is a concave mirror. What kind of mirror it is? It is a concave mirror. And when will we get concave mirror providing a virtual image? When a concave mirror provides us a virtual image, it is only possible when it is between focus and pole. When it is between focus and pole. Now, what is given to us? Focal length. Focal length is 20. Focal length is 20. So, rather than doing any kind of calculation, we are just to observe the options and to find out which length is less than 20 centimeter. So, obviously 25 is not, 40 is not, the answer should be 10. Answer should be 10. Hence, our answer over here is C. Answer over here is C. Okay, this is how you will find the answer for it. Sometimes some options itself provide us the answer rather than doing any kind of calculation. Okay, but then we think that our question paper was lengthy. It was not lengthy, it was appropriately timed. But the thing is, we do not think we do not eradicate, or we do not cancel some of the options by observing the questions. Some hints that are given in the question, we ignore those hints. Okay. Next. Magnifying power of a concave lens is, as earlier discussed, magnifying power, it has been asked for a concave lens. What could be the magnifying power of it? Obviously, concave lens is a kind of a lens which is converging, not diverging. It is a kind of a lens which is converging. So, as it is converging, it is going to diminish the size of the image than that of the object. So, size of the image is going to be diminished, hence it should be less than 1. It is always less than 1. For magnifying power of a concave lens, if it were to be asked for a convex lens, then you would say it is greater than 1. And when will we get concave lens as greater than 1? If it were to be a virtual image, then you can say about between focus and pole. But if it were a real image, then we will not get any value of such magnification which is greater than 1. Okay. Chalo. Next, if the power of a lens is minus 2d, power is given to us as minus 2 diopter, what is its focal length? Very easy question. So, these are kind of questions are being asked in the exams. These are the questions which are being taken exactly from the question papers. Okay. So, but then also we fail to answer such kind of simple questions. So, what will be the power, what will be the focal length of the power? Obviously, we will use the formula first. Power is equal to 1 over f. Power is already given to us 2f, minus 2, 1 over f. So, f will be equal to 1 upon minus 2, which is equal to minus 0.5. But what is minus 0.5? In form of meter it is. And all these options, all these answers are given in form of centimeter. So, we have to convert meter into centimeter. We will get our answer as negative 50 centimeter. Okay, so among these options, option C is the correct one, which provides us the answer as negative 50 centimeter. Okay. Yes. One more question of refractive index. That the refractive index of a water is 1.33. The speed of light is inside the water is given to us to be. What will be the speed of light in water? For that we should be aware of the formula of refractive index. What does refractive index formula says? That refractive index from median 1 to 2 is equal to speed of light in median 1 over speed of light in median 2. Speed of light in median 1 over speed of light in median 2. Now, in median 1, it is obviously air or vacuum, if you would say it then. Then in that, our speed of light is given to us as 3 into 10 raised to 8 meter per second. And refractive index over here it is 1.33 upon C2. So what we will get our C2 as? C2 is equal to 3 into 10 raised to 8 divided by 1.33. And as we will divide it, it is going to be roughly equal to 2.26. It is going to be roughly equal to 2.26 if you will divide it then. Okay, so that will be our answer. Okay. Now in examination also, if they are asking you these in form of an MCQ, then you can estimate your answer as rough. You are not required to have an exact answer. But if it were to be asked in a 2 marks question or somewhere else for a 1 marks question, then what is it? You are to give similarly. C2 is likely to be 2.26 into 10 raised to 8. Likely to be 2.26 into 10 raised to 8 because it is highly impossible to find an accurate answer of it. So it's fine if you will write it like this. No marks will be deducted in the exam. Okay. Next, a person went for a medical checkup and found that the curvature of his eye lenses was increased. Curvature is increased. Curvature increase means actually what is it increased over there? Because are we interested in curvature of the lenses? No, we are interested in focal length of the lenses. So curvature is being increased means focal length is being increased. So here they are asking us that the focal length of the given person is being increased of his eyes. Which defect is he likely to be suffering from? Which defect it is likely to be suffering from? So focal length is increased. What does it mean? Focal length is being increased. Focal length of that object, focal length of his eyes is being increased. Hence, it is being diminished. The lenses of his natural eye is to be somewhat thin, thicker. It should be thicker. Sorry, my mistake. It should be thinner and elongated. It should be thicker and elongated. And when we will get such kind of eyes or lenses of our eyes, when we have the disease of myopia. When we would have a disease of myopia. Then and then only it is being stretched, our ciliary muscles are stretching the lenses and it is not able to relax properly. Okay. Hence, the disease which has been caused to that person is called myopia. Okay. Easy question it was. In which part of the human eye is the image of an object formed? This was a very simple question. In which part image has been formed? Obviously, it is formed on cornea. No, it is not cornea. Why? Because cornea is the cells. Okay, it is produced, cornea, it is not in cornea, it is on retina. It is on retina. And what are irises? Irises are just to protect our eyes from dust. That is this irises that you observe, some hairy-like structure. Very good. Correct. Yes, correct, Vidhu. It is retina. Okay. Over here, then pupil. What is the function of pupil? It is to enter light inside our eyes. Okay, so retina is the answer, not anything else. Yes, a person sees an object closer to his eyes, what changes will take place in his eyes? What changes will it takes place in his eyes? Means if the object is been looked very closer to his eyes, then the pupil size will expand. Is the pupil size going to expand? The ciliary muscles will contract. The focal length of the eye lenses will increase, or the light entering the eye will be more. Light entering the eye will be more. Life processes, but in the life processes, the important part is all those 6 processes. You just go through those 6 processes, and you will be good to go for the life process. It's not that much tough chapter. And also we have already covered MCQs of that chapter of biology, entire biology, in the last class, yesterday's class. So you can go through that. You can refer that also. But I would suggest that in life process, the simple part is all the 6 different processes, you learn them separately, and the entire chapter has been covered. No problem over there. So what was I saying? That the person sees an object closer to his eyes, what changes will take place in his eyes? The pupil size will expand. The pupil size is it going to expand? The ciliary muscles will contract. Is the ciliary muscles going to contract? Or the focal length of the eye lenses will increase, or the light entering the eyes will be more. So among these options, B is the answer. Ciliary muscles is going to contract in this case. Ciliary muscles are going to be contracted in this case. Okay. Now, why do stars appear to twinkle at night? So human eye is completed over here. Okay. Why do stars appear to twinkle at night? Stars appear to twinkle at night because the light of the star travels in a different medium, because the distance of the star varies when the earth rotates, because the star changes its position relative to the earth, or because the atmosphere reflects the light at a different angle. What happens over here? Because why does it shows? Yes, beta. Achha. Because why do stars appears to be twinkling at night? It is simply because the distance between the star and the earth is very much far away, and because of that entire distance to be covered, there are many particles which are going to be between our visions, and that kind of disturbance in our continuous vision, it will be observed that they are twinkling. Otherwise, they are not twinkling at all. They are just stars, such as looking like our sun. It is same as our sun, but they look like they are twinkling because there are many dust particles, there are many meteors, there are many asteroids, there are many different planets which are passing through our vision toward the star, and hence it appears to be twinkling. Okay. Something like John Cena, when he does something like this, it will be observed that it is vibrating. It is not vibrating. What happens over there? He is just rotating his hand faster. Okay. So because so among these options, which will be the answer? The distance of the star varies when the earth rotates. No, because the light of the star travels in a different medium, because the star changes its position relative, because the atmosphere reflects the light at different angles. Okay. Chalo. Next. Which options justify that the sun appears red at sunrise and sunset? What was I saying? What options justifies that the sun appears red at the sunrise and sunset? Why is the reason that it appears red? It is simply because the sun rays which are coming from the sun, first they get refracted and they enters into our atmosphere. And inside our atmosphere, there are continuously many particles which are going to deviate which are going to break the wavelength of sun rays, Sun rays is obviously white in color. So it has been broken down into several parts. So over here, the most deviated one is the red light. Most deviated one is the red wavelength. Hence, as it is a red wavelength. Hence, we can see that at sunrise and at sunset, we are able to observe sky as red in color. Okay, or sun appears to be in red in color. 7 colors only red enters the atmosphere. Yes. Okay. Okay. Next. A person got his eyes tested. The optician, again human eye. The optician prescriptions for the spectacles was left eye -3 diopter and right eye 3.5 diopter. Okay, these are the powers which are given to us. Now the person is having a defect of vision called. What kind of defect is it going to occur? Okay, so now what we can do is, as we are aware about the power, we can find the focal length. We can find the focal length of the eye. So what we will do, that P is equal to 1 over F. Let us find for -3. Then we will get -3 is equal to 1 over F. F is equal to 1 over -3, which is equal to 0.66 something. Sorry. 0.33 something. Okay, 0.33 something. Negative 0.33. Now the negative 0.33 or 333, it is in form of a meter. So you will convert into the form of centimeter. You will get negative 3.33.3. Negative 33.3 centimeter. Okay. Now what does this value indicates? Negative 33.3. Naturally, our eyes are very much optimized to see objects which are 25 centimeter away. That is the natural focal length of our eyes. So it is greater than that. Focal length has increased. So what kind of disease it is? It is myopia. Same as the previous question that we discussed. Okay, focal length is increased, so it is a myopia. Now, a person cannot see distinct objects kept beyond 2 meters. This defect can be corrected by using a lens of power. Okay, same kind of question with the help of power, with the help of this value 2 meter. With the help of this 2 meter value, you can find the focal length, power of that lenses. Okay, and when you will find the power of that lenses, you will be able to get the answer. Let us check. The person cannot see distinctly objects kept beyond 2 meters. The defect can be corrected by using a lens of the power. Beyond 2 meters, it is been saying to us. So it is not able to see object which is far away from him. So P is equal to 1 over F, 1 over 2, 0.5 meter. Okay, so 0.5 meter diopter, my mistake. 0.5 diopter, because 2 is in form of meter. 0.5 diopter, so our answer is A. Okay. What is the work done in moving a charge of Q coulomb against a potential difference of volt V? Okay. Now in the starting of the chapter itself, when we are discussing about potential differences, when we come across the first topic of potential differences, what do we observe? First formula of potential difference. How to find potential difference? What is potential difference? Potential difference is nothing but work done on one particular charge to travel it from one point to another point, from lower potential to higher potential. Okay, that is the work done on that particular charge. That is known as potential difference. Hence, over here, we can say that V is equal to W upon Q. And what has been asked to us? They are asking what is work done. So work done can be directly considered as V multiply Q. So among these options, which is such as V multiplied by Q, that is option D. Understood? Clear? Okay. Next, kilowatt hour is the unit of and dash joule in 1 kilowatt hour. What is the unit of kilowatt hour? Sorry, what is the quantity? Whose unit is it? Kilowatt hour. Is it of electric power, resistance, potential, or energy? Kilowatt hour. Kilowatt hour, obviously, it is a unit of, kilowatt hour is a unit of energy. It is unit of energy. We say watt, so it should be of, it should be of power. But no, after the completion of power topic, you will observe in bottom that there is a one more topic of kilowatt hour. Okay, conversion of unit of watt into kilowatt hour. Then you will observe that it is a energy. And obviously now you are not required to find the you are not required to calculate it. Although it is simple, hour you can convert into the seconds. So 3600, kilo means 1000. So if you multiply them, what will you get? 36 multiply 360000. Right now point is over here. You shift point 1, 2, 3, 4, 5 and 6. You are shifting point 6 side, left hand side. So always remember this formula: left increase, right decrease. So as we are going down the left hand side, so right now 10 to the power is 0. So left hand side is going to increase. So 3.6 multiply 10 to the power 0 plus 6. So ultimately it is 3.6 into 10 to the power 6. Hence it is electric energy, which is 3.6 into 10 to the power 6. Okay. Yes, next question. In the following circuit, heat produced in the resistor or combinations of the resistor connected to a 12-volt battery will be. Okay. Now simple thing is, are we required to, first importantly, are we required to find what is the resultant resistor, what is the values of it? Is it going to be required for us to find that? Obviously not. Why? Because when resistors are in series connection, they require more energy. More energy requirement means more energy gets wasted. More heat energy is going to be reduced or will be released. More heat energy is going to be released. Now over here it will be less energy, and as this one is just 2 ampere, 2 ohm, just one particular resistor which is of 2 ohm. So it is going to have less consumption of energy than over here. So so what can we say? In the following circuit, heat produced in the resistor of the combination of the connected to 12 volt will be. What can you say among the options? Same in all the cases, which is wrong. It is not same. Minimum in case 1, that is wrong because minimum is in case 3. Maximum in case 2. Obviously maximum in case 2 because it is in series connection and more than one resistor is being used over there. So maximum in case 2. Maximum in case 3, that is also wrong. It is minimum in case 3. Okay. What is the minimum resistance which can be made using 5 resistors, each of 1/5 ohm? Okay, minimum resistance we are to produce. When can we produce minimum resistance? As we talked earlier in the earlier question, we said that more resistance means more wastage of energy, more wastage of heat. Okay, so in same reason, when we attach all the resistors in the series connection, we will get maximum resistance. But if you want less resistance, what we can do is we can connect them in the series connection, parallel connection. Hence, what would I say? What will we do? We will find 1 upon R is equal to 1 upon 5, and all the 5 resistors are of 1 upon 5 ohm. So we will just multiply it by 5. 5 resistors each. Multiplied by 5. So 1 upon R is going to be 5 by 5, 1. R is equal to 1 ohm. Became option. The option of 1 ohm is not given. Let us consider the last option is 1 ohm. Let us say last option is 1 ohm. Okay, so that will be our answer. Okay. Okay. Now, a student carries out an experiment and plots the VI graph, voltage current graph, of 3 samples of nichrome wire. Means all the wires are of same material. Okay. With resistance R1, R2, R3 respectively. All three has different kinds of resistors, R1, R2 and R3. Which of the following is true? R1 is equal to R2 is equal to R3, R1 is greater than R2 or greater than R3, or opposite one or the different one. But now, right now over here, you are to consider, what you are to observe, that this particular graph is of voltage and current. Okay, but is it the actual graph to find resistance? Obviously not. Why? Because our R is V is equal to IR, and to find R we want voltage versus current. Voltage versus current. So right now you are to restructure this graph as voltage, current, and you will make this as R1, R2, R3. R1, R2, R3. Now as it has been made R1, R2, R3. Yes, correct. R3 is greater than the R2 and then greater than R1. Yes. Correct. So the option should be C. Okay, because R3 is greater than the R2 is greater than the R1, hence that is our option. Just don't observe that it is a voltage versus current versus voltage graph. So it is the R1, R2 and R3. R1 is greater than R2, then greater than R3. But observe what is the graph says. What does the slope of the graph says? Slope of the graph says it is 1 upon R for this graph. For this graph, it is 1 upon R. But what do we want? We want only R. Okay. Chalo. In the current I through a resistor is increased by in the current I through a resistor is increased by 100%. Assuming temperature remains unchanged, the increase in power dissipated will be. What will be the increment in the power? If it is been increased 100%, means let us say that initial current was X. The new current it is generated, it is X plus X, 100% increased. So new current is X plus X. So it is 2X. We can say it is 2X. Okay. So as it has been increased to X, what is the increase in the power dissipated will be? What will be the increment in the power? So first of all, yes, correct, it's fine, right. Maximum will be that one. Okay, so I is equal to X, initial current is X, and this is a new current which is X plus S, which is equal to 2X. Now over here they are asking increase in power, increase in the power. So for that power increment, initial power is equal to I square, VI. P is equal to VI. P is equal to VI. Now as P is equal to VI, we substitute new power. We'll find new power. New power will be equal to V into 2X. And I can say 2 times VI, because X is nothing but I only. So it is not 400%, it is going to be 200%. It is not heat formula, I square RT. It is not I square RT. It is power formula, VI. So from VI, we can say it is 2 times I is equal to 2 times Vi, which is equal to initial and new. New power is equal to 2 times initial power or old power. Okay, so with this calculation, we can say it has become 2 times. So how much times it has been increased? It has been increased 200%. Okay. So next, 3 resistance of 1 ohm. 3 resistance of 1 ohm each are connected to form a triangle. The resistance between any two terminal is. The resistance between any two terminal is. Now, as they are connected in a triangular formation, we are just to take, we are just to consider any two terminals for ourselves. Let us say these two are the terminals for us. These two are the terminals for us. Okay. Now for these two terminals, what will you observe? That these two resistors are in series connection and they are in parallel with this third one. So R1, R2, R3. For that, what can we say? Our resultant R1 plus R2 is equal to 1 plus 1, which is equal to 2 ohm. And R3 is equal to 1 ohm. But R1 plus R2, which is new R, is in parallel with R3. Is in parallel with the R3. Hence, what can I say? 1 upon R is equal to 1 over R1 plus R2 plus 1 over R3, which is equal to 1 over 2 plus 1 over 1, which is nothing but 1 plus 2 by 2, 3 by 2. So, value of R is equal to 2 upon 3. Value of R is equal to 2 upon 3 ohm. Hence, our answer is C. Our answer is C. Okay. A cylindrical conductor of length L and a uniform area of cross section A has resistance R. Another conductor of length 2L and resistance R of the same material has area of cross section. Now what they are asking, that length is being changed, but resistance remains constant, material also remains constant. What will be the new area? They are asking about new area. So what will we do? We will find first original resistance R1 to be rho L by A, L1 A1. Rho is not going to change because material remains constant. So we are not going to change rho. Again R2, but also what is it saying? The resistance remains constant. So we will say it is R only. This is R. Rho, L has been changed from L to twice L upon A2, which is what we are required to find. Hence, if we will, and let us say this A1 is our A itself, because here it is given that cross section is capital A. Now, if we'll equate these equations, what we will get? Rho L by A is equal to rho 2L upon A2. So rho gets cancelled out, L gets cancelled out. A2 will be equal to 2 times capital A. So our new area of cross section should be double than the cross section of the original ones. This is L then. Okay. Clear? Easy? These kind of simple questions are being asked in the boards. Okay, but because of some pressure, because of some headache in our mind, or what do we think, we messed up in the exam. But just calmly observe the questions, calmly try to solve the questions, you will be able to get your answers easily. Okay. Do not get hampered in the exam. Next, which of the following is not attracted by the magnet? A very simple question. Not attracted by the magnet, which do not provide any kind of magnetism, which are not ferrous material. Among these which are not ferrous material are the ones which are not going to attract toward the magnet. Obviously from this option we can say it is a brass, because steel, nickel and cobalt, they do produce, they are all attracted toward the magnet. The magnetic field lines inside a long straight solenoid carrying conductor, field lines inside a long straight solenoid carrying current is the same at all the point, is 0, it decreases as we move toward its end or increases as we move toward its end. They are asking about solenoid. In solenoid, if we have observed, what do we observe? That in solenoid magnetic field lines enters, forms like this. So this would be our south pole, this would be our north pole. This would be our south pole and this would be our north pole. So from this particular diagram, from this particular observation, what do you say? It remains constant. It is same at all the point. It acts as, solenoid acts as a bar magnet. Solenoid acts as a bar magnet. When it is been traveled, when electricity or current is been passed to the solenoid. When current is been passed to the solenoid, it acts as a bar magnet. Next. The metal rod PQ is placed in the magnetic field. Metal rod PQ is placed in the magnetic field, and magnetic field is going upward direction, is in upward direction. At the end of the rods are connected to a battery. So current is passing through here. But can you tell me what is the direction of the current? It is not shown over here. What is the direction of the current? Is it going from the left hand side or right hand side? Is it going from the left hand side or right hand side? It is traveling like this or like this. What can you say? It is a flow of current, because flow of current is not given to us. It is just said that it is P and Q rod. They have provided a hint. What kind of hint? They have provided a terminal of cell. Here is a positive terminal, here it is a negative terminal. So what can we say? From positive terminal current flows. So the direction of current is in this direction. It is going in this direction. Okay, and magnetic field lines are upward. What do they want to find? Where will be the rod move? What is the motion of the rod? They want to find motion of the rod. Hence, we will use Fleming's left hand rule. Okay, with the help of left hand rule, where this is force, this is magnetic field, and this is flow of current. So current is flowing in this direction. It is in the magnetic field lines is going in the upward direction. So what can we say? What is the direction of? Motion of the rod? It is going to be outward, out of the field. It is going out of the field, not upward, not downward. Upward it cannot be. It is the same direction of the magnetic field lines. Okay, downward it cannot be. It is opposite the magnetic field lines. Into the field means it is going inside, or it should coming outside of the field. So obviously it is outside of the field with the help of Fleming's left hand rule, where this is the motion, this is magnetic field, and this is flow of current. Flow of current is in this direction from P to Q, and magnetic field lines are upward direction. So what can you say? What is the flow of what is the motion of the rod? It is coming outside the board, so it is out of the field. Okay. An alpha particle is diverted toward west, is deflected toward north by a field. The field is magnetic in nature. What will be the direction of the field? Now the important part is here, it is an alpha particle. It is an alpha particle. Alpha particles are positive in nature. If it were to be electron, then what would you say? Whatever is the flow of direction of electron, whatever is the flow of direction of negative field, electron, opposite to that is the flow of current. But as it is alpha particle which is positive in nature, whatever is the flow of alpha particle, that is the flow of, that is the direction of current. That is the direction of current. Now what is it saying? An alpha particle is diverted toward west. It is in west direction. Now is deflected toward north. From west to north, it is traveling from west to north. So north, south, west, east. It was going on a west direction. It is deviated from west to north. By a field. The field is magnetic in nature. So flow of current is in this direction. Motion, where did the motion happen? Motion happened in the opposite upward direction. Then they are asking the field is what is the direction of the field? What is the direction of magnetic field? So from this left hand thumb rule, what can you say? What is the magnetic field lines? It is going toward the why upward. It is not upward. It is not downward also. It is toward, means if you deviate, consider this in three-dimensional form, then your option should be why downward. It is not downward. Why it were to be downward? It is option B, toward east. It should be toward east. It is not downward direction. It should be toward east. Okay, with the left hand thumb rule, left hand Fleming's rule, what will you get? As flow of current is in this direction and the motion is in upward direction. Hence, it is coming outside the board. As there is no option outside the board, you will consider the east, west, north, south direction. In it, it is in east direction. Chalo. The mains power supply of a house is through a 2 ampere fuse. How many 50 volt bulbs can be used in this house at the normal voltage? At the normal voltage, a main power supply is of a house is about through a 2 ampere fuse, and how many 50 watt bulbs can be used in this house at the normal voltage? Okay. The normal voltage, what can be the number of bulbs that we can use in this normal voltage? What is normal voltage? It is 220 volt. Normal voltage is 220 volt, and our power is 50 watt. Hence, with the help of power and voltage, if you will find P is equal to VI, then 50 divided by 220 is equal to I. Hence, what will you get your answer as? 2.5 by 11. Two point 2.22 something. 2.22. Your current will be, flow of current will be 0.22 something. Now it has capacity of 2 ampere. So what number you should multiply with 0.22 to get your maximum ampere? It should not be exceeding 2 ampere. So from that, it is the 8. It is going to be 8. 8 to the 16, 1, 6. 8 to 16, 17, 1, 7. Yes, 1.7 something it is. It is 1.7 something. So how many bulbs can you add over there? You can have 8 bulbs in this situation. Okay. You are just required to find what is the current taken by one particular bulb. And then you multiply it by the number of bulbs that you can consider. You will get your answer. The main power supply of a house is through a 20 ampere fuse. When a 1500 watt heater is used in this house, how many 100 volt bulbs can be used simultaneously? A supply is of 220 volts, same as household one, and the appliances are rated for 220 volt. Okay, here also same type of question, 20 ampere. Now it is 20 ampere. Okay, and each bulb has a power of 100 watt. Okay, when a 1500 watt heater is used in this house, 1500 watt heater is already been used in this house. Okay, and 20 ampere is the 20 ampere is the current flow of current. 20 ampere is the flow of current. Okay, now 1500 is the heater. How many 100 watt batteries can be used simultaneously? Okay, so same thing. P is equal to VI. Your voltage is 220 multiplied by your current is 20, which is equal to 4400. Your power is 4400. Among these 4400, 1500 is fixed. 1500 is going to be consumed by your heater. So 4400 minus 1500. So you will get your answer as 2900. So 2900, what will you multiply with 100 to get 2900? You will get 29 as the answer. You will get 29 as the answer. Yes, correct. If you have written the answer right now, then 40, correct. Okay, then option B is the answer, 29. Okay, simple thing. What will you do? You will find total power outage. How much power will be required? For that, voltage is given, ampere is given. With that, you will get total power capacity. Total power is 4400 volt, and 4400 volt when subtracted from 1500, what will you get? 2900 watt as the answer. That is reserved for bulbs. One bulb consumes 100 watt of the power. So how many bulbs will consume 2900 watt? It is 29 bulbs. Rectangular coil of copper wire is rotated in a magnetic field. The direction of induced current changes once in each. Direction of magnetic field can change in each. How much direction it is going to be? How much change in the direction it is going to be? Yes, correct. Astha Singh, I guess. Yes, Astha Singh. It is in 1 revolution. It is in 1 revolution. Very good. Right, correct. Next, the frequency, the last question, it is the frequency of direct current DC is. Frequency of direct current. What is the frequency of the direct current? For alternate current we have frequency, but for direct current we do not have any frequency. For direct current there is no frequency, so the frequency of the direct current is 0. Sorry. Frequency of the direct current is 0 hertz. Frequency is only for alternating current, because in alternating current we continuously change the rotation. So how much rotations it is going to change, that decides frequency. But for direct current there is no requirement of alteration. Hence there is no requirement of alteration, so it is going to be 0. Yes, correct Asta Singh. It is to be 0 hertz. It is to be 0 hertz. Okay. Chalo. Thank you so much for being with me through this entire lecture of I guess 15 minutes. Okay, I enjoyed a lot with you to provide 30 MCQs over here. I hope this would help you in your examination, and as of now I would be liking to leave the class, but I would want to meet you again. Okay, bye bye. Thank you. If you like this, then please do share, subscribe, and like the channel.